Let us start with stress. The stress is defined as internal elastic restoring force per unit cross-sectional area of the body. This can be written in equation form as stress equal to internal elastic restoring force upon cross-sectional area. We already know that the internal restoring force is equal to the applied external force. Therefore, the stress can also be defined as the applied force per unit cross-sectional area of the body. In equation form, we write it as stress equal to applied force upon cross-sectional area. By representing force as capital F and cross-sectional area as capital A, we write the equation for stress as stress equal to F upon A. The units of stress in MKS and SI systems are Newton per meter square or Pascal. The CGA unit of stress is dyne per centimeter square. The dimensions of stress are L raised to minus 1, M raised to 1 and T raised to minus 2. A strain. All real rigid bodies are to some extent elastic. This means that we can change their dimensions, that is size and shape, slightly by pulling, pushing, twisting or compressing them. The change in dimensions per unit original dimensions is called as strain. In equation form, it can be written as strain equal to change in dimensions upon original dimensions. The strain is the ratio of two similar quantities. Hence, strain has no unit. Strain is a pure number. Types of stress and strain. When an external force acts on a solid, it may change its dimensions in three ways. The three deformation types have the concepts of stress and strain in common. The applied forces in all three cases produce deformations in the bodies. The stresses and the corresponding strains take different forms in these three situations, but the stress and strain are proportional to each other within an elastic limit of the material. We will know more about elastic limit in a short while. Tensile stress and strain. Consider a situation where a cylinder is stretched by two equal and opposite forces applied normal to its cross-sectional areas. The restoring force per unit area is called tensile stress. If the cylinder is compressed by two equal and opposite forces applied to its cross-sectional areas, the restoring force per unit area is called compressive stress. These stresses together are known as longitudinal stress. In both the cases, there is a change in the length of the cylinder. The change in the length delta L to the original length L of the cylinder is called longitudinal strain. In both the cases, there is a change in the length of the cylinder. The change in the length delta L to the original length L of the cylinder is called longitudinal strain. In equation form, we write longitudinal strain is equal to delta L upon L. Similarly, in equation form, the tensile stress is written as tensile stress equal to applied force upon cross-sectional area. The MKS unit of tensile stress is Newton per meter square and CGS unit is dyne per centimeter square. The dimensions of the tensile stress are L raised to minus 1, M raised to 1 and T raised to minus 2. The tensile strain is defined as the change in length per unit original length. The tensile strain is also defined as the ratio of change in length to the original length. In the equation form, the tensile strain can be written as tensile strain equal to change in length upon original length, that is equal to small l upon capital L. The tensile strain has no unit. In this type of elastic behavior of the body, the shape of the body is maintained. Tensile stresses occur in rope climbing, bicycle chain, and cables of lift elevator.